I know this one.
Yeah. So I'm just explaining it again. Okay. So from here, what happens? There will be the reflection. So due to that refraction, what will happen? There will be the dispersion. Dispersion means there will be the here. If you are placing a screen, okay, in front of this, suppose this is your prism, this is your screen, and this is your white light ray. So here, different colors you will get: red, orange, yellow, green, blue, indigo, and violet. These colors you will get. Okay, you can see this phenomena like this. Here, refraction is basically taking place for different colors. So the different amount of refraction is taking place. Okay, so this is known as the dis dispersion of light. Basically, the splitting up of white light into 7 colors on passing through a transparent medium like prism is called dispersion of light. Basically, this light is passing through this prism, and this light is converting, or this light is splitting into the 7 colors. So basically, what this is showing, this showing that the light is made up of 7 colors. So basically, this experiment is done by scientist Newton, Isaac Newton. Okay. Basically, this is the dispersion of light. Okay. Now after that, hello Martin. Hello
Yes.
Martin. Now your internet is okay.
Yes.
Now we will discuss what are the real life examples of the splitting of light or dispersion of light. Basically, this red color has the maximum wavelength and violet color has the minimum wavelength. So in real life, there is one beautiful example: rainbow. I don't know whether the rainbow is beautiful or not, but that is the example. Okay. So now, if what I am doing after that, after this experiment, a ray is passing through this prism, and 7 colors you will get on the screen. A band of 7 color you will get on the screen. Basically, this is the screen. This is known as the dispersion of light or the splitting of light. So it is clear from this experiment by Newton that light is made up of 7 colors. Now there is one more experiment done by Newton. Same experiment, not the same. Uh,
And
this
sir,
experiment.
at times there are like soap bubbles, and then there is
Yeah,
light
yeah, yeah,
thread.
yeah, yeah. You are right. Bubbles is also that in bubbles. Sometimes there is a splitting of light, basically. Okay. Now recombination of the another prism. Now earlier what is happening? Earlier what you have done here, na? Here one light and here is one prism. Ray of light and one prism is there. So finally you are getting colors, 7 colors. Finally you are getting. Now suppose you have placed a inverted prism. Inverted prism means this combination. Earlier the refracting surface is this. Now this phenomena you already know. Here different colors of light will be there after the dispersion. After the dispersion, different current colors of light will be there. And when you are placing a prism like this, so in such a way that the refracting surface, because these lights are entering this now, entering to through this surface, through this prism. So here what will happen when you are placing this prism like this? Again, due to the refraction, again this is happening, this is due to the refraction, there will be the recombination, and again finally you will get a white light. And if someone is asking why there is a recombination, what will you say? There is an equal and opposite type of refraction will be there when you are uh, placing a prism in this condition. Okay, and you will get, basically this is also done by the Newton. So if the white light is made up of 7 colors, if you are made 7 colors, if you are just mixed those 7 colors, again there will be a white light now. If the white light is made up of 7 colors, if you will just combine that 7 color, you will get again a white light. So here is the combination of the recombination of the 7 color. Here is the splitting of 7 color. So splitting of 7 color is known as the dispersion. And after that, if you are placing a prism in this way, you will again get the recombination of the colors, and after the recombination, again you will get the white light on the screen. So this is explained here. The first glass prism disperse. Disperse means splitting the white light into 7 colors. The second glass prism, which has been placed as upside down, recombines the 7 color of the spectrum to give back the white light. So why this recombination of white color or white light is taking place? 7 colors is taking place. Recombination of 7 colors is taking place because you have placed a prism in the upside down position, and due to the refraction, due to the here also there is a refraction, but here the refraction is taking place in such a way that there is a recombination of the colors. So basically 2 points we will write here. If someone is asking in examination why uh, there is a recombination again when you are placing a prism, so you will write this. The recombination of 7 colors produced by prism is due to the fact that due to the fact that the second prism has been placed second prism has been placed in reverse position in reversed position. This thing we know, okay? Reverse position, due to which the refraction produced, or you can say the refraction you can write produced. The refraction produced by second prism is equal and opposite to that of produced by first prism. So basically this will be the language that you are going to write in the examination, and for the understanding purpose, you know that here is a white light, here is a dispersion taking place. When you are placing a inverted prism like this, again these 7 color will recombine due to the refraction, and that refraction is equal and opposite by this, okay? Earlier the refraction is taking place on this surface, after the refraction is taking place on this surface, so the inclination of surface will also decide how the refraction will take in place, okay? So again you will get a white light. Now on the basis of the dispersion of light, we will discuss the rainbow. Basically rainbow is a phenomenon due to the dispersion of sunlight. So rainbow will be seen when there is a sunlight and at the same time when there is a rain. So what happens there? The droplets of that rain behaves as prism. So basically what happens, droplets, on that droplets the sunlight falls, and those droplets are behaving like a prism, and due to that there will be the scattering, not the scattering, dispersion or splitting of light into 7 colors. And after that there will be one more phenomena that I will tell you, total internal reflection, and you will get that uh, rainbow in the sky. So this phenomena is taking place basically. Rainbow, how the rainbow forms in the sky. This is the raindrop. Okay, what is this? This is the raindrop. Droplet, rain droplet. Okay, so this is the raindrop. What is happening? It is written already here. Okay, no problem. So basically this is the raindrop. Just focus on the screen, I am just explaining it. Okay, this is the sun. So rains falling, rain, take any one raindrop to just understand that phenomena. We have taken one raindrop. This is the raindrop. We have considered the shape of the raindrop is spherical. So what happens here? Sunlight is there. There will be sunlight. I have told you the rainbow will be there when there is a sun and there is a raining at the same time. So sun is also there, raining is also there, raindrop is also there. Raining, due to that raining, there will be the raindrop. So there will be a sunlight, or you can say white light from the sun, and that will be fall. This is the surface of the raindrop, and when this light will fall on the surface of the raindrop, there will be the diffraction. There will be the splitting or dispersion of light. Means this white light, due to the refraction, there will be the dispersion. Basically this is a white light. At this point B, there is a refraction, and due to that refraction there will be the dispersion of light. Dispersion means that this white light will convert it into the 7 colors: red, yellow, blue, green, all that you know. And from here all these colors now will be here, and at this point there will be the total internal reflection. All the colors from this fall here, all the colors will be here, and from here these colors will be totally reflected from the surface, from the inner surface of the droplet, and like this, the after the reflection, here again there will be the refraction, and due to that refraction again there will be the refraction, and after that, suppose you are here, this is your eye, this is you, this is your eye, and you are able to see these colors in the sky or the atmosphere. So basically this is the basic fundamental of the rainbow. That's how we are able to see the rainbow. Three phenomena are taking place. First is the refraction. Basically at B there will be the refraction, and after that there will be the dispersion, and after that again after that there is total internal reflection, and after that there will be again refraction. Okay, so basically this is looking like this also. This is a white light. So from here, this is a raindrop. So this raindrop I have told you behave as a prism. So this raindrop will behave as prism. Tiny prism. Tiny means a small prism. So now another with the another diagram, if you want to understand, this is a white light, here splitting of light, and here see, here total internal reflection, total internal reflection is taking place here at this region. Okay, so at this region, what is taking place? Total internal reflection. Okay, so light, this is the splitting of red light, and red light fall on the surface of the drop, and it will be again reflected. And now you can see this is a water medium, and this is a air medium or atmosphere. So here refraction will taking place. So in this way the red light will be there. Accordingly there will be yellow, orange, green, indigo, blue, violet, and accordingly you can. Okay, so if you want to draw you cannot, I think, draw this thing in the exam. If you are able to draw, then it is better. You have to use the sketch pens, and this also, I think, this will be difficult to draw. So basically in the exam you will, if you can draw this will be okay. If they are saying that how the rainbow forms in the sky, then you will say there is a raindrop there, and from this raindrop dispersion of light ray, this dispersion of the white light takes place, sunlight takes place. So basically you will show two lines like there. Here this is the dispersion. Basically this is the, here is the dispersion, and you will show here will be the total internal reflection, total internal reflection. So I think this diagram is comparatively easy. So here is total internal reflection. So here, from here, this light will be fall on this, again strike on the surface of the drop, internal surface, and reflected like this. And now this light will be here, and at this point there will be, and at this point there will be refraction again. So I think this diagram is better too, and just show there is red color on the top and violet color at the bottom, and in between there are another colors also. I am not saying that there will be only red color and violet color. Violet color. This is the diagram that I want that you should draw in your exam if you are not able to draw these or these types of the diagram. So basically this is the rainbow. Now we will write some theory regarding this rainbow. So what is rainbow? Basically the rainbow is an arc. Uh, the rainbow is an arch of 7 colors visible in the sky uh, due to dispersion. Dispersion means splitting. This dispersion of sunlight by raindrops. By raindrops in the atmosphere. Basically, raindrops will be in the atmosphere. In the atmosphere. So rainbow is, this is the rainbow, and there is one more point that you can write, and each raindrop, each raindrop will behave as, will behave as small or tiny glass prism splitting the sunlight into spectrum. Okay, so you can write one here also, splitting sunlight into a spectrum into 7 colors, you can say, and those 7 colors are known as the spectrum. Okay, this is a rainbow, and there is one more point I want to tell you. uh, Suppose I am here. mm, mm, basically rainbow is always in the opposite direction of the sun. Okay, why rainbow is always in the opposite direction of the sun? Suppose sun is behind me, and this is the rainbow. So what, from the sun, okay, from the sun, light rays will coming towards me like this and falls on the raindrops. Okay, and splitting of light will take place. So I am not going in that detail. Basically this is enough for the rainbow. So what you will do now? mm, Arshia, are you able to draw this diagram, or do you
Yes,
want
sir.
to take? Can you draw this easily?
Yeah, I can.
Okay, so Martin and all that, and Hamna, if you are able to draw this diagram, then please draw it. Otherwise, you can take the screenshot also. Basically, this is the topic recombination by the another prism. So this is also done by the Newton. Okay, so draw this. I have explained why all these things are happening. And write down this also. Okay, Martin.
Yeah, okay, sir.
So it's all clear now.
Yes, sir. Rainbow.
These are the phenomena that you have already seen. Uh, I uh, I can say that I have seen the rainbow. Okay, I have seen the rainbow. Maybe you have seen or not. Whether I have seen the rainbow, and basically rainbow is the phenomena due to the splitting of light into 7 colors. Basically, splitting of light into 7 colors in the atmosphere or sky. So after the rainbow, we have the atmospheric refraction. Very easy topic. In the atmospheric refraction, we will discuss there is a twinkling of stars. Why there is a twinkling of stars. Okay, when completed, please ask me to scroll down, all of you.
You can scroll down.
Okay. Should I move to the next slide?
Yes, sir.
Martin, Hamna?
I'm doing so now.
Okay, fine. You can tell me when finished.
Okay, sir. Okay, done, sir.
Yeah. Okay, so what you have to do? Just wait. I'm telling. Okay, you can just draw this diagram. Okay, so these rays you can just show like this. Okay, you have to what you have to do basically. You have to draw a circle first like this. Okay, this is a circle, and if here you will show that a ray of light is entering like this, and from here you will show the splitting like this. Okay, 3 4 or okay, and from here you will show that light rays are totally internally reflected like this. Can you do this now? And after that there will be the refraction taking place, so you can just show that like this. Okay, okay, so in this way please draw this diagram. You will get full marks if you will draw this diagram in your exam, because this is the whole phenomena that is happening for the formation of the rainbow. This is explained in this diagram. Write all the things At this point V, there is a refraction. This is the dispersion. At point C, there is total internal reflection of a spectrum. At point D, again is the refraction. Why? Because this time the light is moving from denser to rarer medium, and this is the observer. It can be you, it can be anyone, can be any other person.
Yeah, answer.
Arshia and Hamna completed.
Yes, sir.
Hamna completed. Okay, so you can in simply you can draw this diagram. Okay, so no, I think there is no need now. Okay, if you have drawn this, so no need to draw this diagram. So now write this. What is the rainbow? Write down this. Completed? Matthew and Arshia and Hamna?
No, Sandy.
Okay.
Yes.
Hamna, are you writing?
Yeah, completed, sir.
Completed. Now we will have one question. Sweet. Okay, so after that we will have the atmospheric refraction. So now see what is atmospheric refraction and why there is a refraction in the atmosphere. For example, suppose this is the Earth. This is the Earth, okay, and this is the surface of the Earth. So when you will go like this, these are the layers of the air. There is air na above the surface of the Earth. Atmosphere is there. So this is the atmosphere. And when you go up to the, this is the Earth surface. When you move up to the surface, you will go in this direction like this. So there are the layers of air. There are the layers of the air, and as you are moving up, as you are moving up, the temperature of the air layers will increase. Okay. Okay. The layers of the air which are far from the surface of the earth have high temperature, and due to that they have the uh, high they have the low refractive index. Okay, they have low refractive index, and this layer will have high refractive index. Why this have high refractive index? Because this layer will be at lower temperature, and this layer will be have higher temperature. And these are the air layers. And this is the earth, and basically this is the surface of the earth. Okay, these are different types, different layers when you will go up. And now what will happen, somewhere here will be sun. This is sun. So basically what will happen, low refractive index and high refractive index. So basically sunlight will be there like this. Okay, sunlight will be there, and there will be the refraction. Okay, there will be the refraction of sunlight, and this is known as the atmospheric refraction. Okay, so low refractive index to high refractive index means the light ray will move like this. Okay, so the light ray will move like this. This is the normal. When the light ray is moving from here, here will be some another layer. Okay, here will be some another layer. Here will be some another layer, and that layer will have again low refractive index. Low refractive index means what is happening here? Here is the rarer medium, and here is the rarer medium, here is the denser medium. So what happens when a light ray is moving from rarer to denser? Matthew, it will
Is
move. It will move to, towards the normal and move away from the normal.
it moves prior to denser, right? It moves towards the normal.
It will move towards the normal like this. Okay. So from here also the light ray. Basically, I want to tell you, na, due to the different refractive index of the layers of the air, there will be the refraction of the sunlight, and that refraction is basically known as the atmospheric refraction. Okay. So if you want to show, then it is better, and if you don't want to show, then also it will be okay. If you will write the definition, then also it will be okay. So just I want to show you how these things are happening basically. So here the light ray will be like this. Bend towards the normal. Okay, so this will be the light ray. So here is the refraction taking place. And why this refraction is taking place? Because of the layers of the air. So you can write here, in the same atmosphere, in the same atmosphere, we have layers having different temperature, or you can say due to that different temperature, the layers have the different refractive index or different optical density. Different, you can write different optical density. Basically, refractive index is a measure of optical density. Refractive index. So keep in mind this thing, and the refraction of light caused by the refraction of light caused by Earth's atmosphere is known as Earth atmosphere is known as atmospheric refraction. Refraction. Okay. So why there is an atmospheric refraction? Because the layers of the air have different refractive index. Ri means the refractive index. So note down it fast, all of you. So due to this atmospheric refraction, we will see different phenomena like the twinkling of stars, like the stars are appear farther than their actual position. So all these phenomena are happening due to the atmospheric refraction. So I have given just a basic idea how there will be the atmospheric refraction. So in the next class we will discuss it. Basically in the next class we will finish this chapter. Okay, Hamna and Martin, write down this.
Okay, sir.
Almost no problem. You can take time. So suppose this is the surface of the earth and you are moving away from the surface of the earth like this. You are moving in upward direction like this. So the temperature of the air will increase, will decrease. Oh, sorry, will increase. The temperature of the air will increase, and due to increase in the that temperature, the refractive index will decrease, or you can say optical density will decrease. And why the refraction is taking place? Because of the different refractive index of different layers of air in the atmosphere, and that is known as the atmospheric refraction. So this is basically the normal. Basically, this is the atmosphere. Oh.
That answer.
Completed. Oh, okay. So, okay, completed. Martin. So, Martin, do you want to ask any doubt?
No, sir.
So, can you tell me one question? At this point D, why there is a refraction in the rainbow? In the
Because like
in the hmm?
because it hits the water droplets. The water droplets is like a prism, behave like a prism.
Hmm? No, no. Here at point D, this is the water droplet. So light is coming from the water droplet to the air. Outside there will be air, na? Air.
Yes, sir.
Here will be air, na? So basically, the light is traveling from denser medium to rarer medium. Water is a denser compared to air. So light is traveling from denser to rarer. That is why here at this point refraction is taking place.
Oh, so
You have to
it,
understand. You have to understand all the phenomena, all the thing. Each and every question you should know. Okay. Here, why here at point B the refraction is taking place? Why?
Because
Why? Because here will be air and here will be water. This is a
so
water droplet, na? So light ray is changing the
appearance.
medium. Light ray is changing the medium. So due to the change in the medium, refraction takes place. And here will be total internal reflection. Simply here will be the surface, and due to the surfaces, we have seen the reflection from the